All right, so today we're going to now solve, some questions, few questions on. We're going to apply everything we've been learning on, conditions for equilibrium, moments, and everything. So if you're not very familiar with this topic, I'll advise you pause this video, go back, 2, 3 videos before this. That's where we started explaining everything about moments, a basic introduction. Now I want to solve, and this is actually a basic question, right? This is one of the very basic questions you're going to see. This is just the basic level, so we're going to keep increasing the difficulty level, as we keep comprehending the basic ones. Now, without further ado, let me just solve. Let's solve. All right. So we have two, masses hanged on this meter rule. So this is just like a beam, right? We have the knife edge. This is the knife edge. That's the turning point. So any moment we are taking, we're going to take it from this point. This is the turning point of this beam. And the question is simple. Find the value of W. You see that we have two weights. One of the weights is given a mass, actually 50 gram. One is labeled W, and we are told the distance, from this turning point. So this is very simple. I'm just going to apply the principle of moment. So what's the principle of moment? Now, what do you notice? Notice that this beam is in equilibrium because it's not, it's not tilted to one side. It is horizontally balanced. It's perfectly balanced, meaning it is in the state of equilibrium. So, since it's in the state of equilibrium, we're going to apply the conditions for equilibrium. And in this case, you see that we cannot use this condition that has to talk about the forces in the y, because all the forces we have here are forces in the y, and they are all in the same direction, because the direction of this force, weight, is acting downwards. So this is acting downwards and this is acting downwards. So that condition cannot be of any help to us, so we're not going to apply it. So what we're going to apply is moment. All right, we're going to apply condition of moment. For this to be balanced, it means that the clockwise moment must be equal to what? Anti-clockwise moment. As simple as that. All right, so let's solve. Which of these force, which of these masses is going to create a clockwise moment? Now remember, this is our turning point. I think I'll just highlight it. So this is the point about which you're taking our moment. Now look at this. Notice that this weight, this mass W, will tend to turn this system in this direction. Which type of moment is this? This is clockwise moment. All right, so take note of that. This is a clockwise moment. Why this? Relative to this our turning point, it will turn it in this direction. So which type of moment is this? This is anti-clockwise, as you can clearly see. All right, that's not how the hand of the clock turns. So we know that the 50 gram mass will have an anti-clockwise moment and W will have a clockwise moment. And then what is moment? Remember the formula for moment. Moment is simply force times the perpendicular distance. All right, so for the clockwise moment, we have the force there is W, unknown, which you want to find the value, multiplied by the distance. What is the distance? What's the distance from the turning point? Notice that this is 75 and this is 50. All right, so 75 minus 50 is what? That should be 25. So the distance will be 25. Okay, now they didn't give me anything. We are not given the units of the distance, whether it's in centimeter or meter, but it doesn't really matter, right? Because since we're looking for W, we have the unit in grams, so we are good. Okay, we're saying that the clockwise moment must be equal to, what is the anti-clockwise moment? That's the mass there is 50 grams. Now, mind you, gram is a unit of mass. All right, so since the question did not specify anything, I can work with that. All right, I can work in mass. I don't necessarily have to convert it to weight. All right, but if you're writing an exam, you may want to convert to weight. All right, because when we are taking moments, we use force, and that force is in Newton. This is in gram. So converting, just in case you want to do it, if you want to convert mass to weight is simply mass times acceleration due to gravity, all right, which is g, and this g is 9.8 meter per second squared, or you can just approximate to 10 meter per second squared. All right, however, Also take note that the mass must be in kilogram. All right, so take note that the mass must be in kilogram. All right, but it's not necessary in this question. I can just solve in gram. So this is 50 grams. What is the distance? All right, from 10 to 50 is 40, because if you do 50 minus 10, you're going to get 40. So the distance from the turning point, remember, we're always taking the distance from the turning point. That point you're seeing like a triangle, that is the turning point. It is the point about which the whole beam can rotate. So whenever you're taking moment, it is necessary and imperative to identify and take note of the turning point. Please, this is the most important thing in moment. As soon as you shift the turning point, the moment is going to change. It might still return, in its direction, whether clockwise or anti-clockwise, but the value is going to change. All right, because the bigger the distance, the bigger the moment, shorter the distance. I've already discussed all of this in the introductory video. Now, W times 25, we can just say this is 25W equal to 50. 5 times 4 is 20, right? You just add the 2 zeros, that's 2000 G. Now, we just need to divide both sides by what? By 25. Okay, so we now have that W is equal to we can use 5 into 25 will be 5 into 20 is 4, this will give me 400, and 5 into 400 is just 80. So the value of W is what? 80 gram. So that's the mass of that mass labeled W that will keep this system in equilibrium. This is it for this question.